name is Michael Frank. Got my colleague Chris Eberly with me here today.
Thanks everybody for coming to us this morning.
We both work for Avanade Australia. Chris is based up in Brisbane.
So I'm a cloud marketing unit solution architect based in Brisbane for Avanade, working in Azure for about 4 years now and doing some of the largest projects that you may have seen mentioned here at the conference as well over the last 2 years.
Yep. I'm based down in Melbourne. Do similar work to Chris. We actually work together on a project. With our last project, we migrated about 1,000 VMs up into Azure and about 5 petabyte of data, so it was quite a lot. Anyway, so when we talk to our clients and when we do the cloud migrations, we always get asked the same things. And one of these things is, how do we secure our data once it's up there? How do we encrypt the data? What do we need to do to have everything up there secure? And Key Vault, our topic today, that's definitely one of the pieces of the puzzle to do that. So what we want you to do is to take a few things away. So we want you to understand how you can use Azure Key Vault to secure your keys and your secrets, and then how you can use your keys and your secrets to encrypt your workloads in Microsoft Azure. The session today, we're going to talk first about why you should encrypt your data and what Azure Key Vault is. That's our intro, and then we'll dig deep into how you're actually going to do it. How can you use Key Vault? And we go into a couple of demos, and we probably spend quite a fair amount of time in the demos. And throughout the demo and throughout the presentation, we'll talk about the pitfalls that we encountered with our clients and some of the complex configurations. Feel free to ask any questions anytime. I will ask a couple of questions every now and then. But yeah, if you want to know something in specific, let us know. And if we don't get to your question, come up later and we'll talk about it. All right, so with that, let's get started. And we're going to start with a quiz. Who knows what these identities here have all in common? Right, hacked. Chris, can you give him one of those little things there? So they all got hacked, and they all got hacked in different ways. The first one is really, really interesting. Anybody from the Philippines here today? Yeah, 1, 2. All right. So what happened with the Commission for Elections in the Philippines is that they have a website, and the website is accessing a database with a lot of the voter data. There's a lot of email addresses in there, passport numbers, and other things. And on the website, you as a Filipino could go onto the website, search yourself, and find out where your closest voting station is or something similar. So that database got compromised, but it was encrypted, which is great. But on the other side, that website that was accessing the database, in the PHP code, they had the connection string unencrypted in the PHP code, and people were able to just go there and download the data and then do whatever they want with the data. So definitely not good. Sony got hacked. Probably a lot of us got affected, mainly because the PlayStation Network went down in 2011, which wasn't good over Christmas. But there were also some unencrypted credit card details that were up there that wasn't that good. And Sony Pictures itself got hacked in 2014, and there were a couple of leaks around personal data, employees and families. We had confidential emails and salary information out there, and luckily for us, some films got leaked, which might have been a good idea, or might have been something nice. Who knows about Red Cross Australia? What happened with Red Cross Australia? Troy Hunt did a couple of good blog posts about that. So with Red Cross Australia, somebody went out and just scanned all the public IP addresses out there, and he scanned for .SQL or for SQL database backups. And he found a few. And when he found one, he downloaded one, and he extracted it, and it wasn't encrypted. So he had all the data, and that data turned out to be the donations data from Red Cross, from the blood donors. Red Cross already confirmed that besides him finding the data, it wasn't really compromised or used for anything bad so far, but who knows. And lastly, my friend John. My friend John, he's a bit of a funny guy. He likes his music in his videos and downloaded stuff and got the CryptoLocker installed on his machine. All the data on his machine got encrypted, and he had to pay somebody a couple of Bitcoins to get his data back, which wasn't fun. Anyway, so why I chose these 4 entities is really to showcase you that, first of all, it doesn't really matter how big you are. Sony is one of the biggest organizations out there, and you, my friend John, nobody knows my friend John but me. So it doesn't really matter how big your organization is and how small you might be, you can still get attacked by cyber criminals. On the other hand, we know that encryption is important, so Red Cross Australia should have encrypted the database. But also, if you do encrypt your databases, it's important to not only encrypt the database, but to also secure all the connection strings and the secrets that might give you access to that database. And coming back to my friend John, encryption can also be used as a bad thing. And from my friend John, we learned that if you don't own the keys to the castle, if you don't have the key to unencrypt your data, that's quite bad for you as well. Anyway, so what's the state of encryption in the cloud nowadays? So Sophos did a survey between 17,000 IT managers in America last year. And they figured out that about 84% of those companies involved were concerned about storing their data in the cloud. They were concerned about different things. Obviously, protecting company data is one of the highest ones. Everybody wants to protect their data, but they also want to protect the employee data or have actually security policies in there that makes them aware that they should protect their data. Interestingly, out of these 1,700 IT manager companies, or IT managers in their companies, 80% already use cloud storage. But even though they were aware that there are attacks out there and they might get negative press and everything, only 39% of those companies encrypted the data, which is a bit concerning. And if you ask them why they don't encrypt the data, they come up with, oh, we don't have the money for it. It's really, we don't want to encrypt the data because it might cause some performance concerns, and we don't know how to do it. With the last one is what we're going to try and address today. So Chris, tell us a little bit about how we secure resources in Azure.
Thank you, Michael. So as everybody knows, I'm sure that everybody has spent some time in Azure and started to get an idea of the breadth of resources and capabilities that we have in Azure today. Microsoft goes a long way to help us protect our data as best we can, and they have a variety of mechanisms already in there today that can be used to leverage that. For instance, the SQL PaaS platform that they provide has basically a switch in there to enable us to encrypt our data and look after it that way very simply. A lot of the storage accounts should be accessed just over HTTPS to encrypt our data in transit, as a couple of examples. But we're going to focus today predominantly on your side of the fence, on the platforms and the systems that you need to take some action of to look at and protect your data in the cloud. So in particular, virtual machines and protecting and encrypting the data disks that are being used to run your virtual IaaS fleet in Azure. Also, your SQL servers that you might be playing in there in IaaS. So in today, SQL PaaS is not the only solution to run SQL databases in the cloud, and they're not always the right solution for your architectures or application requirements. So we see a lot of IaaS SQL platforms that are placed into Azure, and there's better options to encrypt the SQL data using TDE encryption or transparent data encryption, and how we can use Key Vault to protect that key that's used to unlock all of that. And the third one that Michael's already mentioned is connection strings and applications that you're developing that you're going to get more junior people to actually deploy those resources in Azure and operate those platforms. And those people may not be at a sufficient clearance level to actually have the credentials that are being required to do certain things in that application or to deploy that application. So how do we actually reduce their administrative levels to the minimum footprint so that we can securely protect their applications and their connections? So in the quest to secure these resources in Azure, particularly what we're looking at today are secrets, which are free text type objects that we can secure and protect and encrypt. So we've mentioned connection strings. So in your application development, you'll want your application to go and connect to a database of some description. So we should be able to remove that connection string out of our code, which might be visible on the internet, and put it somewhere else and put some other security in there in place to actually only retrieve that information when it's actually needed. Credentials, if you're using scripts and PowerShell to actually join machines to domains in your network as part of your provisioning process, Why not take that domain join account capability out of your script and stop storing the passwords in your scripts and put it somewhere else, and use some other mechanism to actually retrieve that information on demand when it's only required, so that you're not storing that in clear text anywhere else. And other secrets. So in application development, there's all sorts of information that you need to access but don't necessarily want to have in clear text floating around. So we should be able to move that somewhere else and look after that as well. The second thing that we're going to talk about is keys. So encryption and decryption keys. And again, those keys are basically the key to unlock your data and retrieve it and access it and also protect it. So those that have got any experience with keys, you'll know the two basic types of keys that we have that we'll utilise. A symmetric key, which is the same key that's used to unencrypt and encrypt your data. So if you have that particular key, then you can access the data, you can encrypt it, you can decrypt it. So that's a very powerful key in its own right, as well as asymmetric keys, where we use a different key to encrypt the data than we use to unencrypt the data. So using those two keys together, we have one side which encrypts our data and another one that unencrypts it. So the private key in that particular pair is actually a very powerful key that we don't want to get out into the wild. And it's worth pointing out, for those that aren't too familiar with symmetric and asymmetric, why we have those two types of mechanisms in play and why they have different purposes. A symmetric key, the encryption and in particular the decryption process is actually quite quick. So if we're looking at transparent data encryption of a database in SQL, the actual data in the database we'd actually secure with a symmetric key because we want to get to that data really quickly, but we want to secure it. The asymmetric keys, the public key side actually takes a lot more compute and a lot longer to actually do the decryption. So for objects that we don't need to access very regularly and we want a higher level of security placed around them, we'll use the asymmetric key process. And the third thing that we want to secure is our certificates. So we use certificates for a range of things for securing and encrypting our data. And again, those keys are very powerful out in the wild. If you've got the key for certificate key for a website and the private key that's being used in that certificate to protect that website, if that's leaked, then there's potential usage, particularly with the wildcard type certificates, for it to be used for not so good purposes. So what sort of things do we actually need from a security model to actually protect the information that we're trying to secure here and stop the bad guys from getting to it, but at the same time actually make it easy to actually use and access and not overly burden our IT teams to actually manage these platforms. So one of the first things we actually want to do with our secrets and our keys is we actually want to encrypt them themselves. So we want to actually make sure that if they're actually accessed or there's a breach, that the key itself has actually been encrypted, so it can't actually be used if it was actually stolen. So it's encrypted at rest. Our choice of deployment location, particularly in the world at the moment, sovereignty of data is a big issue for a lot of companies and organisations. So we want the ability to be able to use a key vault or a storage place where it's most appropriate for an application or a sovereignty or a data protection matter. Choices of how we actually encrypt and look after our data. We have various levels of protection that we want to provide with our systems. In a development environment, we need to be able to still secure that, and we want to continue using the same security processes, but we don't want to pay a high price for actually securing that in a development environment. The risk of loss and the risk of damage that's caused if a loss occurred is a lot lower than a production system. In a production system, we actually want to start looking at using hardware appliance level capabilities, which are a lot more secure and a lot more robust. And then also when we're protecting our information in there, as I said before, we want to be able to encrypt our keys and our secrets. So we also, in certain instances, want to be able to bring our own encryption key to encrypt the data that we're going to store in our key vault. So we'd rather not just rely on Microsoft's generated key that they're going to use in default. An organisation may have a higher profile or higher risk that they want to address. They want the ability to use their own key to protect their keys. The security module separation. We want to protect keys for various applications and for various purposes. we don't necessarily want to store all of our keys in the same physical vault. We want to have some separation there as well. So if you're protecting and using a development environment where your security and your role separation might be more relaxed, you don't want to use that storage location to store your production systems as well. So you want to be able to have that sort of isolation. And as I said before, these solutions need to be easy to access and have a sufficient amount of rights control to have separation of duties. So they need to be simple to use, simple to manage, and efficient. Those that have been involved in managing secrets and keys in an organisation using best practices policies will know that role separation and role separation of duties and segmentation is a very critical aspect in the whole management lifecycle of security. And lastly, not least, most organisations today are very cost conscious, so we want a very cost-effective solution, something that enables us to reduce our costs and overheads again, and something that now enables smaller organisations that don't have the security budgets of the enterprises to be able to achieve the same level of security that they can. Traditionally, an enterprise environment would have had to have gone out and bought a hardware appliance called a hierarchical storage module appliance, which locks away the keys, and they're very specialised pieces of equipment with very high very stringent security controls wrapped around them, and they're very expensive devices, far out of the reach of a small business. But a small business today has just as much need and requirements to actually protect secrets as well. So, Michael, how would we achieve those solutions?
So let's have a look at the security model. So we talked about a security model, a hardware security model. So that's really the place we store our secrets and our keys. And Key Vault is one of these hardware security models, or one of these security models where we can store our secrets and our keys. So looking number one, secret and keys are encrypted at rest. In Azure Key Vault, we have all the data that is in Key Vault encrypted at rest. They are getting encrypted with the key encryption key that we talked about earlier. And that's all stored in there. I'll get later to different versions of the Key Vault. We can have the keys encrypted in a software vault or a hardware vault, and that would be the difference between standard and premium. Choice of deployment country or choice of deployment in general. We can deploy the Key Vault to any of the Azure data centers, and we can choose into which resource group we want to deploy the Key Vault. It does make sense having the Key Vault close to the application or the purpose that you are using the Key Vault for. So if you have some of your data in Europe, you want to deploy them in Europe, and if you have your SQL data in Australia, you want to deploy a Key Vault in Australia. Choice of the encryption method. So we have standard versus premium edition in Azure Key Vault. Standard, whenever we store a key or secret in a standard vault, it will get encrypted by a hardware security model, but then it will get stored in a software vault. In the premium edition of Key Vault, it will get encrypted by a hardware security model, and then will actually be stored on a separate hardware appliance where you store your keys. BYOK, bring your own key. We already touched on this. That's the ability to bring your own key encryption key, the master key, if you would want to say so. And we can do that with Azure Key Vault. The only thing that you do need is you need to have an actual physical appliance already on premises in your data center. You generate the key there, and then several operations that you need to do to get that key into your Azure Key Vault. Security module separation. Azure lets us create as many key vaults as we want. There's no cost associated with creating a new key vault. So we can really create one for dev, one for prod, one for our secrets, one for passphrases. We create one for our VMs, for the BitLocker encryption keys. We create some for TDE. We might even go down into the TDE and say, okay, this application, this key vault is only for this specific SQL TDE encryption key. Easy access and rights control. We have several things here. So we have role-based access control overall in Azure. We then can use Azure AD to apply these roles to certain identities in Azure AD, and we can manage that via the portal and via PowerShell. And lastly, low cost. The way how you pay for Key Vault is per operations. So you pay 3 cents per 10,000 operations, so it's not that much. If you do have a premium key vault, you will also pay $1 per key that you store, key and secret that you store in the key vault. If you create multiple versions of a secret, you can create several versions of a key or separate versions of a secret. You will pay $1 per version per key/secret per month. And if you haven't used that secret or that key for up to 90 days, afterwards you don't pay for that anymore, but you will pay for the first 90 months. That's really already everything about Key Vault, what there is to say before we get into it, how it actually works. So we'll just summarize these things here. So it's cloud hosted, it's hardware security backed. You can encrypt all your keys and your small secrets in there. You can import and generate your keys. You can actually ask Key Vault to generate your keys for you. You can actually ask Key Vault to do simple SSL tasks for you, where you can say, can you please renew this SSL certificate for me? And then Key Vault would go to a few supported CAs, go there, renew your SSL certificate for you, and then put the new SSL certificate into your store. All the keys stay within the boundary. If you create a asymmetric key, the private key stays in the Key Vault and you can't actually get it back once it's in there. You can back up and restore the keys, but once it's in there, it's stored in there forever, unless you delete it. Key Vault itself deploys in minutes, comes in 2 flavors, we talked about this, and the cost is quite low. Are there any questions about Key Vault in general so far, before we get into how it actually works? No? Great, I'll keep the giveaways to myself. So let's talk about how it actually works. Chris will talk to us about the different roles and identities involved in Azure Key Vault.
Thanks, Michael. So in Azure Key Vault, as I mentioned before, one of the requirements we really want in a security module management is role separation, so that we have different tasks in the process assigned to different people, so they can't collude to actually short-circuit the system. So the primary one is the Azure admin or the Key Vault owner, who creates the Key Vaults and allows applications and users access to the system. And they also manage and update permissions and can delete keys which are no longer required by the organization. The key or the secret owner is the person in the security team would actually generate the keys and add and remove secrets to the platform. So they will have the rights to actually add and insert information or remove information from them. And it's important to know that that person shouldn't necessarily have access to the applications or the scripts that are going to use or rely on those secrets or those keys. That's the role of the application owner, the person that needs to actually write the code or access the key to achieve a task or a role or a process in their system. So they're going to configure their application to actually access the Key Vault and retrieve the information, but the application owner is not necessarily going to have access to the actual contents of the Key Vault that application is going to require or that process is going to use to achieve its end goal. And that brings to the application or the Azure resource itself, which is the component which is actually going to use that information to achieve its goal. And the last one is really the auditor. So from a cybersecurity team and an IT team in general, you want to be able to audit these systems. And the auditor needs to be able to see what's been going on, but shouldn't actually have access to the contents of the information that's being stored in that Key Vault. So they're the 5 primary roles that you would associate with the Key Vault platform. And if you look at them as a logical group there, you'll see that there's various tasks that are assigned, but no one person in a large organization would have that end-to-end capability to be able to create the Key Vault, create keys, use the keys, and delete the keys, and then review the audit logs of that activities themselves. That sort of bypasses the whole purpose of actually securing and managing a key platform in its own right. So that's what leads us on to the next step in the exercise then, which is how this whole process fits together and what are the steps that are involved in actually being able to use a key in an application or a process. So the first part is that first role that we spoke about, which is the admin role and the Key Vault owner that's going to create that Key Vault for us in the Azure environment where we're going to put it. They're going to do 2 things. They're going to create a service principal identity, which will be used later on, and they're going to create the Key Vaults and configure the access for the service principal to be able to access the keys that are going to be created for that particular purpose in the key vault. So they're going to create the key vault, they're going to assign some permissions for the service principal, and as part outside of this workflow process, they may also assign the rights for the auditor as well. After that's happened, we've got a key vault set up and ready to go. The key or the secret owner is then able to then actually create a key or a secret and store it in the key vault. So that person will then create that key, put it in the key vault, and it's ready to actually be used by the entity that needs to use that information. So once that key and secret owner has actually done that, he'll then actually inform the application owner that that information is in the key vault and it's ready to be used, and he'll provide them with the service principal identity, which is actually a special Azure Active Directory identity that's used to access the information, and he'll give him the name or the reference to the actual key or the secret, which is actually a URI that refers to what's inside the key vault and that particular key or secret that application owner is going to need to access as part of their system. The application owner is then actually going to configure their application on their Azure resource with that service principal information and that key and that secret URI. So that application is given the information that it needs to actually be able to be authenticated by the Azure Active Directory and the reference point in the key vault where the secret or the key that we're going to use is being stored or located. So at this point in time, we still haven't actually exposed any actual secrets or credentials that have been stored in our key vault. So the application then gets run, or the Azure resource goes and operates. The first thing it's going to do is going to use its service principal identity that's been granted to go and verify itself against the Azure Active Directory and authenticate itself. And the Azure Active Directory is then going to give it a token back. So it's actually going to use a token that's been authorized at that point in time. So again, Azure, we're not actually going to then actually continue using that service principal identity and its authentication. We're going to retrieve it with a token, which is a little bit like Kerberos, which is basically a ticket. Then the application is going to send that token to the key vault, and the key vault's going to validate that token and authenticate it and make sure that it's actually valid and it's a live token. And if it meets its criteria, then it's actually going to access the key vault and retrieve our secret or our key and give it to our application. And at that point in time, the application's then able to use that information to do whatever it needed to use that information for, whether it's to join a server to the domain, or whether it's to connect to a database string, or to pass credentials to something else.
Chris, how would the auditors fit in here? What would the auditors do?
Yeah, so as I said before, the role separation, the audit role doesn't actually take part in the actual activities that we've just seen there. Those activities there are separate. So that auditor role basically has visibility over the activities and the logs that are occurring on the key vault and is able to see what activities are going on. It's not actually involved or able to interact with the processes of the key vault being used. So again, you have that clear separation and the inability of the auditor to go and manipulate the information that's going on in that key vault. So very clear lines of separation, which is very important for cybersecurity people and risk managers to be able to ensure the integrity of their systems. So now we've got the idea of how the key vault platform works. I'm going to hand back to Michael, and he's going to start doing us some demonstrations about how we actually do this in the real world.
Cool. So what I come up with is just a small company scenario. We have a company called the AAAF, the Australian Association for Alternative Facts. They had some data leaks lately, and we came in as a consultant, and we had a look at the environment and figured out, hey, there are a couple of things that you need to change, right? So the first thing that we found is that they have a couple of PowerShell scripts, and in the PowerShell scripts, they have storage keys and credentials in there. And we said, okay, cool, we're going to take those credentials, put them up into Key Vault, and then call them during the execution. The second thing that we found is that their Windows servers, they are not encrypted. So we want to go ahead and use BitLocker to encrypt those VMs and store the BitLocker encryption key in the Key Vault for that. And then lastly, we found that they had a SQL server, and the SQL data itself was not encrypted either. So we're going to go ahead and use TDE within SQL to encrypted database, and the actual TDE key we will store in the key vault. We will store the public key, the private key in the key vault, and then in SQL we're gonna go and grab the private key for the public key. Right. 5. See if this all works. Yep. So what we're seeing here is the Azure portal, and you can see the current resource group that has all the information in there. First thing that I actually wanted to address is storage account encryption, which is quite a interesting process once I get my mouse. There we go. So Azure actually gives us the option to encrypt the storage account. So if you go into a storage account here, and we look up the encryption option, once it's loaded. Container encryption. We could enable the encryption here. Now at the moment it's disabled. If we enable it, any new data that would go into that storage account would get encrypted with a key that Microsoft provides. Thinking about this and how much sense that makes, how much sense it makes is probably up to you. But what it would mean is that if I take a truck and I drive it into a data center and I'm going to one of the racks and I figure out which of the databases had your data, and I grab it, take it out, plug it in somewhere else, I couldn't get that data because it's encrypted. But the likelihood of that is probably quite low. If I still have the storage account key and I connect to Azure, I can still get into that storage account and get that the data in there. So it's really more like a physical protection for your data. However, we can enable it in here. I think it might make more sense to do it in PowerShell. I like PowerShell, so what I'm going to do throughout the demo is I'll show it to you in the portal, but then anything that I do, I will actually do in PowerShell.
So while Michael's looking at that, the whole reason that you want to use that base level storage account encryption is that a lot of organizations at a bare minimum want to have their data encrypted at rest, whether it's in the cloud or on-premise. We should be trying to encrypt our data at rest, and that mechanism that Azure has given us gives us a very simple, quick, and painless way to ensure all our data that's going to be stored on a storage account in Azure is encrypted at rest.
So what I'm going to do here is I'm just going to have a quick look at the storage account. You can see that if I look up the storage account, it does give me a encryption tag. So that encryption tag is currently blank. If I go ahead and I apply the encryption, we can see that changed. So we'll just do this before we go ahead. Great. So now that we ran it, we can see that under encryption we have the storage model encryption enabled. So the next thing that I said is that there is a script that is currently using some secret in plain text. I'll put the script up here, and it's a really very basic script. All it does really for our demonstration purpose is take a blob. We have a backup file here. That blob is currently in the unencrypted storage account. It has a key that is in plain text, which you can't see on the screen for some reason, but you can see that the second one is in plain text. And we now want to take that destination and the source key and put them into the key vault. So the first thing that we need to do is create a key vault itself. Now the key vault can be created in the portal and via PowerShell. I'm going to show it to you in the portal first. That's really nothing complicated. You go into key vaults, and then in here you have the option to add a new key vault. You give it a name, and you give it a location where you want to store it. You can choose if you want to create it in a new resource group or an existing one, and then you click create and it will do it for you. Again, we're going to do it in PowerShell. That's the wrong one. So a PowerShell commandlet for that looks like this. You can see the -SKU, which gives us the option to create a standard or a a premium key vault. And after we run that, we can see the storage account in the portal itself as well. Interesting part, if we look into the key vault itself, we can see the principals that currently have access to the keys. So at the moment, there's only one principal in there. That's my account because I created it. But we could go ahead, and what we do later is we're going to create a couple of principals in here to access the back and the TDE application IDs. Secrets itself, you see it's currently empty. So let's go ahead and convert those storage account keys that we have. We're going to create them into secrets. So the first thing I do is I'm going to grab the current storage account keys from the storage account. I'm going to convert them into a secret string, and then I'm going to upload them into the key vault. So there's not really anything complicated about it. As I said, I grabbed the keys, converted them into strings, and then I uploaded them. If I go ahead and I'll now call the secret, you can see that I get the ID for it that I can then later use to put into my applications. Cool, so now what we need to do is we go back into our script. And in our script, we need to replace the source key with a command that would call the key vault and the secret text value for the key vault. So for our source key, that command will look like this. So we go and get the Azure Key Vault secret from the vault name, and we give it the specific name, and then we take the result of that command, and we look up the secret value text. And we do the same thing for the destination key. And that's pretty much it. That's all we need to do. So in our existing scripts, we pretty much just need to upload our keys. We need to make sure that we have access, so that whoever is going to go and run the script has access to the key vault. And then in the script itself, we need to just replace our current value that we have with the plain text string with the result of our command to get the Azure secret.
So the nice thing about this approach is that traditionally with the script as it stood before, anybody in your organization could have run this script and done this activity, whether they were supposed to or not. By taking this approach, the context of the identity of the user that's running PowerShell and as the identity that's being used to actually access the Azure subscription, that identity actually has to be given permissions in the Azure Key Vault to access our secrets. So only the authorized group of administrators or users of this script are now able to actually run this script successfully. Anybody that's not having the right credentials to actually access the key in the vault is automatically going to fail and not be able to run this script. So it actually provides a second advantage, as well as actually protecting your secrets. You've actually found another mechanism to very quickly restrict the people that can actually use these scripts and run these scripts in your organizations.
So that's cool. So I just checked. So the blob has been copied. So my demo was successful, this first one. Hooray. Now we do the second one. So in the second one, we have a VM, and we want to encrypt that VM with BitLocker. So let me just connect to it. So that's the VM. As you can see, there's nothing special about it. It's really just a default VM. We have the C drive. At the moment, it's unencrypted. If I would go ahead and look for BitLocker, I wouldn't find it because it's not installed yet. That's going to get installed with the extension. Oh, it's actually there. Ha. Okay, in 2012, it's already there. In 2008-02, it will get installed with the extension. However, what we do see is that we do have two drives at the moment that are unencrypted. So what we need to do here now is, first of all, we need to go ahead and create a new key vault. So we want to have our key vault for our VM separated from our secret, so it makes sense to create a new key vault. we also need to enable a specific option in the key vault that will allow Azure to talk to that key vault at the time that the VM starts. What's going to happen is that when we enable the BitLocker encryption, a bag will get created. That's a BitLocker encryption key. That BitLocker encryption key will get stored in the Azure Key Vault. And then at the start of the VM will try to get to the key vault. It will try to get the bag to unlock the encrypted volume. And with the additional option that we're going to include in the script, it will allow the VM to talk to the key vault. So back into our script. So the first thing we do is create a key vault, as I said. And in the key vault, the important option that we have in here is the enable for disk encryption. That's what I talked about before. Now, the second thing that we need to do is we need to create a Azure identity that BitLocker can use to connect to the key vault itself. So we can do that in the portal. In the portal, we would do that under Azure AD.
Now, the interesting point about this particular identity that Michael's about to create is this identity is only required during the actual extension installation and the initial key generation and the key transfer into the key vault. So this identity is going to be used by the BitLocking process to actually pick up the key and install it and insert it and store it into the key vault. So those that are familiar with the keys that are used on these service principals or these identities know that you'll generate a key valid for 1 year or 2 years. You don't actually need to worry about them for this particular process, because once the key is in there, this tag or this flag that we set on the key vault enables the Azure Fabric to actually access these keys when it's required to actually be able to unlock our virtual machines. So once this identity is installed, the key in the vault, that identity isn't actually needed again in this process.
Correct. Great. So in the app registration, to create a identity, I would do that in the portal in here, and I could give it a name. It does require to put a single sign-on URL in there. Because we're not going to use that for this purpose, it doesn't really matter what you put in as long as it has a valid HTTP / and then domain name in there. But again, we're going to do that in PowerShell because it's faster. So I'm going to go ahead and create the service principal first. As you can see, the service principal has a client secret. And we're going to create the Azure application in there, and then we're going to create a service principal which will get registered against Azure Active Directory. And after this, I'm security aware, so I do not want to have that secret in plain text. So I'm just going to store the secret as a value in the key vault as well. And after I've done that, I will give that Azure Service Principal access to the key vault that we just created. Now the interesting part here when we give it access to the key is that it has specific permissions that this Service Principal needs. So it needs to be able to have permissions to the secrets, and it needs to have set permissions there, and it needs to have permissions to the keys to wrap specific keys in the key vault. It needs that permission because what it does is when it takes the bag, it will actually wrap the bag with the client secret, with the application secret that we created during the creation of the service principal, which is the password. Cool. So now that we've done that, we're going to create some more variables from the key vault. So we're going to grab the URL of the key vault and the resource ID. And then we're going to go ahead and encrypt our VM by applying the Azure VM extension for encryption. Great. So this now goes ahead and it's going to shut down this machine. So the machine should disappear in a minute or two. It will restart the VM. It will apply all the settings on the VM. It will go and generate a back key, upload that back key into the key vault, and then it's restarting. the VM will talk to the key vault and try to get the back key. Just waiting for it to disappear.
So you do have a couple of options when you go and enable the bit locking process through this mechanism, is that you can choose just to encrypt your operating system disk, or you can choose to encrypt your operating system and your data disk that might be associated with that machine. So that's a switch that can be set on that command line. So in the case of, say, an SQL server, where you don't want to double encrypt, you don't want to encrypt with BitLocker on the disk system as well as the database itself, you would actually encrypt the operating system disk, but you would leave your data disks unencrypted. There are some reasons we might talk about later if we get some time as to why you actually want to use transparent data encryption on SQL instead of BitLocker, because there's some fundamental value adds that you get when you actually use SQL TDE as opposed to BitLocker with an SQL server.
Great. The other thing that we've done is when we created the application service principal, we put in a secret in there. Now, we don't have to use a secret. Instead of a secret, you could also use a certificate. So if you feel like that a certificate is not secure enough, or if you feel that a secret is not secure enough, you could use a certificate that either you created as a self-signed certificate or a certificate that your CA generated for you. If you go down that route, you need to make sure that that certificate is installed on the VM before you run the encryption extension, or else the extension is going to fail. Besides that, when we upload the bag, it's only encrypted with that specific service principal secret. So either the bag is going to get encrypted with the secret that we're going to put in, or it's going to get encrypted with the certificate that we use when we create the principal. Now again, there are some complications with that. If we do that, if we only use a secret or a certificate, if we'll try to back up the VM via Azure Backup, or if you try to use Azure Restore, that will fail because Azure can't actually access the data. Azure can't get there. So we need to give Azure a way to enable it to back up the VM, and the way how we do that is to encrypt again the bag that was already encrypted with the KEC.
The key encryption key. So you wrap the back key inside a key encryption key, and that mechanism allows the Azure backup service and Azure recovery service to actually access the back key if you're going to restore this virtual machine somewhere else or need to back up the server.
All right, so the VM has been restarted. I got kicked off, so let me try see if it already is up again. Not quite there yet. Are there any questions around the VM disk encryption while we wait for the VM to come back up? Yes? That's correct. When you create the certificate, you can choose how long it is valid, so choose how long are valid.
Last time I checked, the maximum I think was 24 months. It couldn't be any longer. Has that changed?
How did you create the certificate? Did you do a self-signed certificate, or did you do something else?
Well, when I was trying, it was self-signed certificate, but then there was actually a key vault documentation saying key vault won't accept certificates that are any longer than that period. It was a
Okay.
measure within itself. So even if you try to generate something further, you wouldn't accept it. Is that something that has changed since last?
Not that I'm aware of, Chris.
No, so I think it's the same as the secret for that application identity string that you're going to use. As I mentioned before, that application identity or service principal that's going to be used to encrypt the machine and set up the BitLocker, that identity is only actually needed during the installation and the setup process. So if I went with Michael here with encrypting this virtual machine, now that he's actually done it, I could actually go and delete that service principal identity that was used in the creation process, because now the Azure fabric will actually deal with retrieving the back key in its own right for this particular virtual machine. So the certificate may actually be the same scenario there. that once you've actually set this up, you don't need that certificate anymore.
Oh, but I mean, certificate to actually decrypt, right? Because if you set up
For the key encryption key, in that case, yes, you're going to have to.
application is using that certificate and that certificate has expired and
Yeah.
the operational procedures are not in place, fix the risk.
Yes, you're going to.
Until we fix it.
Most likely going to have to get your processes and procedures in place to keep on top of it.
Cool. So we are back on our VM. We can see that the C drive and the D drive now have that little lock in there. If I go into my taskbar, we can see that it is getting encrypted at the moment, and I could run on my general BitLocker management systems again. What has happened while we applied the BitLocker extension to it, that the extension created another volume. That volume is actually stored somewhere completely different to the VM, so you can't actually get to the volume if you would want to go via a storage account. But on that volume, we have our back key stored that has been encrypted with the service principal. And we actually can see two of these. So one of them will be for the C drive, the second one will be for the D drive. If we go back into our portal, we can actually look that up. We can actually see the back key that has been stored in the key vault itself. And we can also see that the principal is there and has the rights to it. So I have the BitLocker app here. Just have a quick look at the secret. There's a bit of a lag between this monitor and my mouse, so I apologize.
So while Michael's trying to find that Beck volume that we saw that appeared, it actually has similar characteristics of behavior as the non-persistent disk that you get assigned when you create a virtual machine. It is a non-persistent disk as well. If you shut down and that virtual machine gets re-provisioned on another host in Azure, Azure will actually recreate a new Beck volume, and it will retrieve the keys and put those keys back into that Beck volume. That Beck volume doesn't get encrypted. It will never be encrypted. It will stay unencrypted to be able to use those keys. And that Beck volume really sort of behaves a little bit like if you've ever used a USB key to be able to start up a server that's been BitLockered. We've used the USB key where you've had your Beck keys stored. It behaves very similar to that here. That's the sort of methodology that Microsoft went to put this together. So that Beck volume, if the server gets rebooted and it stays on the same host, it'll keep that Beck volume there. If it gets shifted to another host, or you move that machine somewhere else, or you delete that Beck volume, or you destroy it somehow, when you reboot that machine and it sees that Beck volume doesn't exist, the extension will kick in and recreate the Beck volume and retrieve the keys again from the key vault so that we can unencrypt our server.
Great. So that was the second demo. So now we go into the third and last demo where we're going to encrypt a SQL database. First thing that we're going to do, again, we want to create a new Azure Key Vault to separate it. We're going to create a premium account this time. And then we go ahead and create another Azure Service Principal. So we already ran through that, so I'm just going to run the PowerShell commandlet for that. So again, we do create a new Azure Key Vault here. That's a premium account this time, just because we wanted to do that as well. We have created a new Azure Application Service Principal. We have given the Azure Service Principal access to that newly created Key Vault. And what we also have done is we have created a new Azure key within that new Azure Key Vault. So if I look up, it's probably easier to see it in the portal. In the portal, we have this new SQL TDE keys that I created. That key vault has two principals, so it has myself, but it also has the SQL TDD app. That's the application service provider that I created. And under keys, we now have a SQL TDE key that we created via PowerShell. So now we go and connect to our SQL server. On our SQL server, the first thing we need to do is install an extension for SQL that lets SQL talk to Azure Key Vault. That is going to take about 5 seconds.
So this particular extension that Michael's installing is actually Microsoft's EKM, Encryption Key Management for SQL. So there's a generic option in SQL to actually use third-party EKMs to manage your encryption keys. So if you're using a Talos HSM device, something like that, Talos might actually have their own connector which enables your SQL server to talk to the Talos HSM platform. In this situation here, we want to talk to Key Vault, so we're installing Microsoft's EKM code for access to the Key Vault from an SQL server.
Cool.
So most of the SQL DBAs that have worked with encrypting databases and using a third-party appliance to install and manage the encryption keys would be fairly familiar with this process.
Yep, so what we do now is we pretty much just enable a couple of advanced options to be able to use the EKM provider. So that's the first thing that we do. We then create a cryptographic provider called SQL TDE using the EKM that we just installed. If you look up the DLL, you can see that here. So that's our first step. Okay, cool. It doesn't like my PowerShell. But that should already be created if I look it up. No, it hasn't been created yet. Execute that again. So if I look into my cryptographic providers now, I have the SQL TDE cryptographic provider. Cool, so the next step is to create the connection to the Azure Key Vault. It's a bit confusing here because the naming convention of SQL and Azure does not quite match up. So what we need to do here is pretty much just tell SQL how it gets to Azure Key Vault. So we create new credentials, and the credentials, the identity is actually the name of the Key Vault. And the secret for the credentials is a mix between the, I'm going to try and get it right, the Azure Application ID and the secret that we used in the Azure Application ID. So what we're going to do is we're going to go back into our PowerShell, and we're going to look up the application ID that we have for the application that we created. Sorry, it's the wrong one. Which is this information here, and we're going to grab that GUID and use it within SQL. What we need to do is SQL can't deal with the hyphens when it sends that information to the Azure Key Vault, so we have to remove the hyphens in there. But once we've done that, we can create the credentials, which is successful.
Did you get the last hash? There's a little hash there.
And then we're going to drop the credentials from our own account and going to create a new account. No, wait, sorry, we're not going to drop it yet. We're going to add the credentials to our own account so we can actually do something with the key. So we do this now. And I copy the PowerShell again. So now the credentials are added to my account. And now I can go ahead and connect to the key vault. I'm going to open the existing key that is in Key Vault and then create a new asymmetric key on the SQL server itself. What does it say? Can't really read it. No explanation is getting. Okay, cool. So there was a issue now connecting to the SQL TDE key.
It was still a dash in the application ID string.
Did I?
Created, yeah.
Okay, copy that again.
So while Michael's just fixing that up, as mentioned earlier, why would you want to use SQL TDE over BitLocker? The primary reason you want to really use TDE over BitLocker when you're securing your SQL databases is that when you actually use TDE on an SQL server, it will also then start encrypting your temp DBs. So any data that's shifted into temp DB for processing will be encrypted as well. And by default, all your database backups are going to be encrypted as well. So your data, when it's stored in an SQL server from end to end, is going to be encrypted. If we were just using BitLocker, our database wouldn't be encrypted, our temp DB wouldn't be encrypted, and our backups wouldn't be encrypted. So somebody could come along that's got access to the server, take our database backup to another SQL server and restore the data, and they'll access your data and bypass your encryption on your disk system. So that's a very important differentiation between those two. The TDE encryption doesn't affect the compression if you're going to use compression on your database MDF files. The compression isn't severely affected by TDE encryption. However, your backups, because Microsoft uses a slightly different encryption methodology or algorithm to actually encrypt your backups are actually going to be close to what the uncompressed database size would be.
Nearly there, keep talking.
And a large-scale enterprise as well. Ideally, you want to have role separation between your server administrators and your DBAs. And in an enterprise where you've got some best practices running, your SQL DBAs shouldn't actually be logging on to the actual SQL servers. They should be using the SQL Management Studio from a jump box or from their local machines, if required. There's very minimal activities that an SQL DBA should actually be on a server for. And that forms part of, again, protecting your data and your database servers. That if you're not having those disks encrypted, if the SQL DBA is able to actually access the servers themselves, then there's potential risks there with the SQL DBAs exfiltrating your data. So that's something to keep in mind when you're looking at access to servers, to actually really seriously question. DBAs love to have access to the servers, but if you actually drill into it, there's very minimal use cases where they physically should have access to the servers. They should be able to do most of their activities using SQL Management Studio from a jump box.
That's cool. So while Chris was talking, I actually did manage to create an asymmetric key, and then I dropped it from our account, and I created a new account from the asymmetric key. So that's all good. So now I'm connecting to the database, and I'm going to go ahead and use that asymmetric key to encrypt it. And if we go ahead and check the status on that now, we should see that the database itself is in an encryption status. And as you can see, the encryption is in progress, and you can also see that the TempDB is already encrypted.
So that process is effectively, you can actually encrypt SQL databases and actually store the master key, which is what we call the master key, which encrypts all the other keys and secrets on the SQL server, can actually be stored on the actual physical server itself. But the protection mechanisms that's actually on Windows Server 2012 and earlier servers isn't necessarily the strongest way to actually protect those keys. If you take the server somewhere else, you've basically got the keys to unencrypt your database. So this process here, where we've taken these extra couple of steps, which Michael's demonstrated only takes us a couple of minutes, means that if anybody actually physically took our SQL server or SQL VHD file somewhere else, unless they have the key vault access, which they're not going to outside of your subscription or your region, they're not going to be able to unencrypt your data. So your data is protected no matter where it gets taken away to.
And that's already it. That was our session. So hope we showed you something that you could use in practice. Gonna open it up to any questions that you may have. If not, feel free to come to us later and we'll talk about in private.
Yep.
But, yeah. Yes and no. So if I put the connection string, if I put a connection string into the key vault, I'll create a new application, and then the application needs to have access to the key vault. The question is, by creating that account, does it make it more unsecure? Is that right? And by actually having another username and password just for that specific key, does that make it more unsecure? As risky as.
Yeah, so the scenarios depends really on how that piece of code's being running, probably, in that if that piece of code's running on a server under an application ID context, then the application ID context would be used to verify against the Azure AD. So you're not actually storing that application ID and secret actually in your code. You're actually relying on the identity of the context that the application code is running in. A bit like the other I can't remember what the other process was we showed before, but it was the identity of the person that was running the code, which was required to actually access the vault. So we didn't actually pass any credentials through the system.
I guess it will always depend on the scenario. Like what I did earlier is I had my own account and was logged in with my own account. So it was secure because I knew and I was logged in. And if somebody gets my credentials, then that's bad. But my credentials will not ever be in plain text somewhere, right? For an actual application, I guess it depends on how you access or how you configure the application itself, and that will depend on the application itself.
Yep.
Do we have any other questions? Yes?
Just for encrypting disks in BitLocker, am I right in saying you would need a security principal in Azure AD for every single VM?
No, you can use the same principle for multiple VMs, yes. And the principle is only used to actually copy the backup there. Anybody else? Yep. Say it again, please. In a PKI, to secure the private keys in a PKI scenario. The question was if anybody has used Key Vault to secure the private key in a PKI scenario. And I'm guessing you're referring to a Windows PKI scenario where you actually have a CA. We personally haven't done that yet. Probably would be a good use scenario.
Yeah, I can't say I've actually tried to do something like that.
I think the question will be, can the CA talk to Azure? So is there a way how CA can talk to Azure and actually connect to the Key Vault to get to the key or into the secret? Great, if you have any more questions, feel free to come up to us. And with that, don't forget to continue your learning path. Don't forget to evaluate it for the chance to get a drone pass. And also a reminder to pick up your wristband for the party tonight. Thank you.